Hello students. So today we are going to do exercise 1.3. Okay. So first question is f function is given and g function is given and they are also defined. We have to write g composite f. Okay. So f function is from 1, 3, 4 to 1, 2, 5. G is from 1 to 5 to 1, 3. Okay, I'll not write f and g. I'll directly write g composite f. Okay, so here first we'll operate on f, right? So you have to start with 1. So g of f of 1. F of 1 is given to be 2 and g of 2 is 3. Okay, then g composite f of 3. F of 3. F of 3 is 5. So g of 5 is given 1. Okay. G composite f of 4. So g of f of 4. F of 4 is given to be 1. So g of 1 is given 3. Okay. So g composite f is the set 1, 3, 3, 1 and 4, 3. Okay. Second question is let f, g and h be functions from R to R. Show that. So you have to show this. So let's start. F and G both, F, G and H. All three are from real numbers to real numbers. So we have to show that F plus G composite of H is FOH plus GOH. Okay. So starting with the left hand side. So H of X I'm taking. So F plus G of H of X. So this is then by algebra of these functions we can take f of f plus g of h of x can be written as f of h of x plus g of h of x. Okay. So f of h of x is nothing but f composite h of x plus g composite h of x. Okay, and this is our right hand side. Okay, so similarly we can go from right hand side, that is this we can take, then we can write like this, then this and this. Okay, second one, f into g of composite h, f composite h dot g composite h. Okay, starting from RHS. Composite h of x, h of x. So we can write this as same way as we have done for plus h of x this will come here. Okay, so this is f composite h of x into g composite h of x, which is our, this is left hand side, this is right hand side. Okay, next question, question number 3. Find g composite f and f composite g if f of x and g of x are given. Okay, first f of x is mod x, g of x is mod of 5x minus 2. Okay, starting with g composite f. So g of f of x, g of mod of x. So in place of x, you have to put now mod. Okay, then f composite g of x, f of g of x, 5x minus 2. So in place of x here, you have to put this mod 5x minus 2. Okay, which is same as mod of 5x minus 2. This and this are not same, as this is mod of x. So whatever value we take, if we take negative, it will be positive, right? But here, if you take a negative value, you'll get a negative minus 5, right? So these are not same. You can put the values and check. F of x equal to 8x cube. G of x is x raised to 1 by 3. Okay. So G composite f of x is g of f of x, g of 8x cube. So here you have to put 8x cube. Okay, so this is cube root, right? So 8 cube root of 8 is 2, and this is x. F composite g of x, f of g of x, so f of x raised to 1 by 3, x raised to 1 by 3, you have to put here in place of, in f you have to put this x. So in place of this, have to write 1 by 3 raised to cube. Okay, so using the laws of exponents, this is x raised to 1 by 3 into 3. So the answer is 8x. Okay, so these are totally different. These are not same. Okay. Next question, question number 4. F of x is defined like this. You have to show that f composite f of x is x. For all x not equal to 2 by 3, what is the inverse of f? Okay. So f is defined. F composite f of x is f of x. So you have to put this whole thing here, and then in place of x here, you have to put this. So this is 4x plus 3 upon 6x minus 4 plus 3 upon 6, 4x plus 3, and 6x minus 4 minus 4. Okay, so multiplying this to numerator, you will get 16x plus 12. Okay, this denominator will get multiplied here doing the cross multiplication. So we will get here 18x minus 12 upon, you will get this denominator, right? And here also you will get the same denominator. So both the denominators will get cancelled. Okay, after doing the cross multiplication in the denominator also. So this is 24x, 18, 24x plus 16. Okay, so this gets cancelled. You'll get 34x upon 34. Okay, so this gets cancelled. You'll get x. X is the answer. So you are getting the identity. That is, if you are taking f composite f of x, you are getting the same thing, right? So you are getting the identity. So we can say that f is invertible and inverse exists, and inverse of f is f itself. Okay. Next question. State with reason whether following functions have inverse. Okay. So here some functions are given. You have to write whether the function has a inverse or not. Okay. When does the inverse exist? When function is 1 1 onto, that is it has to be bijective so that it is invertible, and we can say that inverse exists, right? So let's see. F is from 1 2 3 4. Here all the numbers are going to the single point. Okay, so it will be like this. So this is not 1 1. Okay, it is a many one function. So f does not have any inverse. So no inverse. Okay, let's go for the second one. Second one, 5 is going to 4. Okay, I'll write like this. Okay, 5 6 7 8, 1 2 3 4, and 5 is going to 4 4. G of 6 is 3. 7 is going to also to 4, and 8 is going to 2. Okay, here also the same thing, that is G of 5 and G of 7 are same. So this again, it is not 1 1. Okay, not 1 1. So we can say that inverse does not, no inverse. Okay, next question. Third one. 2 3 4 5 7 9 11 13. Okay, 2 is going to 7, 3 is going to 9, 4 is going to 11, and 5 is going to 13. So from this we can say that f is 1 1, and also all the elements in the codomain set are covered. So f is onto. That is range is equal to codomain set. Okay. So both 1, 1 and on 2. So the function is bijective. Function is bijective. So we can say that this h function is invertible. Okay. So it has inverse. Inverse exists. Okay.